So far, we've looked at a few of the what you can consider prereqs for this topic. We saw how angles are measured. We saw what a coordinate system is. We saw the four quadrants, how the x and y values behave. We learned about terminal sites and how we can identify which quadrant the triangle lies in. Our next goal is to look at each of these four quadrants and see how the ratios behave. Now recall the definition of trig ratio. If xy is the terminal side and the length of the hypotenuse is r, concept check, r is root x squared plus y squared. What are these ratios? Now remember SOHCAHTOA, so sine is opposite. Opposite of that is y, so it's y over r. Cosine is adjacent, which is x over r, and tangent is y over x. Now, our first goal is going to be looking at the signs. Where is it positive, negative? Quadrant 1, right? Quadrant 1 is right here. So sine theta is positive, cosine theta is positive, and tangent theta is positive. And this is because x is positive and y is positive. But if you go to quadrant 2, now x is negative and y is positive, which means sine theta, which is positive over positive, is positive. Cosine theta is negative over positive, so it's negative. And tangent theta is positive over negative, which is negative. So what we have here is sine positive, cosine positive, tangent positive. Sine positive, cosine negative, tangent negative. In the third quadrant, x is negative and y is negative. So sine is negative. Right? Cosine is negative. But tangent, which is negative over negative, is positive. In the fourth quadrant, we have x is positive, y is negative. So sine is negative, cosine is positive, and tangent is negative. So we have very distinct behavior for each of the trig ratios in the quadrants. So this is a summary of the result. So we can say that quadrant 1, we have all positive. Quadrant 2, we have sine positive. Quadrant 3, we have tangent positive. And quadrant 4, we have cosine positive. So if you remember which ones are positive, you automatically know that the remaining ones are negative. You can use the acronym ASTC, all students take calculus, and you can memorize to say all positive, sine positive, tan positive, cosine positive in each of the four quadrants. Okay, so we already learned what a terminal side is. Now next we're going to define something called a coterminal angle. Two angles are coterminal if their terminal sides are the same. Example, 10 degrees and 370 degrees. And 370 degrees is 360 plus 10, which means it's one full circle and then 10 degrees. So it ends up at the exact same place. Similarly, 350 and negative 10. Because 350 is positive, it goes counterclockwise. But negative 10 goes clockwise. And it goes exactly 10 degrees clockwise. And they end up at the same spot because the full circle is 360 degrees. Why is this useful is, since the terminal sides are the same, all trigonometric ratios of coterminal angles are equal. For example, sine 370 equals sine 10. Or tangent 10 equals tangent 370. So if you know the trig ratios for one of the angles, you know it for the coterminal angles. Similarly, secant of negative 10 is secant 350, etc. Concept check. Can you create another pair of coterminal angles? You can pause the video and try. Basically, you can just create as many as you want. Each of these are coterminal angles, and you can verify etc. Right? Because any line you draw, there's a way to get there using positive angle, and there's a way to get there using negative angles. Next video, we're going to look at reference angles.